Hey guys, welcome to another video. And today, in this video as well, I'm going to solve as usual what I solve. I'm going to give contest, and this will be weekly contest 481. So yeah, let's see how I can do the contest. Alright, so here we go. Oh wait, I think I have done this already. Did I do this before? Why is this something? What? I think I've already done this. It looks like I've done this. Wait, is it? I think, yeah, I have not done this, but still something. Okay, define the mirror distance as I can do this again. No worries. I mean, there is no way to know if a particular virtual contest is I have already given or not. So maybe it's true that I have already given this contest. But yeah, you given an integer n. This is the integer n, and we're going to define its mirror distance as absolute value of n minus the reverse of n. The reverse of n is the integer found by reversing the it's the usual thing. It's not a very big issue. So int, let's say, call the reverse, which will be so the first thing that I need to do is string s, which will be to string n, and then I'm going to just do the reverse of this thing. And how am I going to do reverse like this? The reverse I can do by giving a string to integer, and this is basically no, not reverse. Like I can do reverse as dot begin and as dot end, and then I can just take the stoy of this s, or so this will be the reverse, and I just need to find out the absolute value abs of rev minus n, and this will give me the answer. I like it's quite an easy question, and I think this will be like, I don't know, I think I've already solved this before, but I don't know, like I don't really know when I solve this question, but it will be a revision maybe, even if I have already solved the question. Okay, so you are given a string s of length n. So I have this s of length n and an integer cost of the same length. Okay, this is also the same length as s, which I am understanding, and cost I is the cost to delete the ith character of s. So a particular cost is going to basically delete the ith character, the cost to delete the ith character. Yeah, so you may delete any number of characters from s. Okay, I can delete any number of characters from s, possibly none as well. I cannot, if I want to delete none of the characters, I can do that, such that the resulting string is non-empty. Right, so the you can delete, but it shouldn't be empty, right? And consists of equal characters, right? So yeah, so basically what it is telling me is that I need to delete such that it shouldn't be empty. It should contain at least it's very simple, I think. What I can do is create a hash table, and yeah, it's quite simple. What I will do is, like, for each of the character, I'll try to add all of the cost that those character has. So let's say for A, I'll have certain cost. So whenever A appears in this S, I'll try to add those costs there, correct? That's what I'm going to do. And for B, I'm going to add all of those costs together. Whenever the S contains B, I'm going to add to the cost of B. So now what I'll do is basically, if I want to keep this A character, it's just going to be total cost minus the character that the total cost that if I needed to keep A, so I'll just remove all those cost which was of deleting A, right? So I'll remove from the total cost from A, and if I find that the cost can never be zero, right? As you can see, it's always positive. So if I find that for some particular character the cost is 0, then I just don't do anything, right? Because I cannot have the empty string. So it's quite simple. I can just make hash of 26 and okay, so I have not defined what n is, so let me define what n is. N is just equals to s dot length, and I'm also going to define the sum, which will be sum plus equals to cost of I, right? And now whenever so in the hash of s of I minus of A, so this is going to give me the index of A or B or whatever the character is in the suitable index of the character, and this I want it to be long, yeah, because this is long, and you can also see the constraint. So I'm going to increase the cost of I to the hash. This is what I'll do. Alright, now what I'm going to do is go through so what I need to find is the minimum total deletion cost. So let me have another which is going to give me the answer, and initially let's say this is max. Now for all of the values of hash, if hash of I exists, if it's not 0, then I'm going to be like, okay, answer is equals to minimum of answer and total cost, which is sum, minus the cost that I will have if I deleted hash of I, which will be hash of I, right? So now if I only have deleted everything except for that character, then this will be the total cost, and then I'll just return the answer. That's it. 11, 13 and 0. So let me submit this. It's got accepted. Let's move on to the next question. So minimum swaps to avoid forbidden values. Okay, so I'm given two integers, nums and forbidden. This is nums and this is forbidden. So there are two integers of length n. So let me define n to be length okay. So now you may perform the following operation any number of times including 0. So again the same thing, I can, if I want to perform I will perform, if I don't want to perform I just choose not to perform. So choose two distinct indices I and j and swap nums of I with nums of j. Okay, so if I can basically choose two distinct indexes, okay, from nums, one index and then another index, and then I can swap the values of the elements. Return the number of swaps such that for every index I the value of nums I is equal to forbidden of I. If no amount of swaps can ensure that every index avoids its forbidden value, if no amount of swaps can ensure that every index has its forbidden value, return 1. Alright, so I can only swap, right? So the thing is, when can I be sure that it will be, that I cannot make it? If the values that I have in nums of I, right, and at least there exists one value which does not match with any of the numbers in the forbidden, then I can say that yeah, I think that's it. That's what I need to do. So I can just sort these two values, and yeah, but if I sort it, then there will be a problem, because I need to find the minimum number of swaps so that I can make it forbidden. So I cannot actually change, so I can just create a temporary variable and then do all the things. That would actually make it better. Right. Okay, so one more thing we can do is yeah, I'm thinking. Let me think what we can do. First of all, let me create a vector A and a vector B, and let me A of n, let's say V and B of n, and A of I am going to just make its value equal to B of I, nums of I, and B of I am just going to make the value to be equals to forbidden of I. Alright, now I'll sort these two okay, now if I think that if I say that if A is not equals to B, then I'll return -1, but if they are equal, then now I need to do something, and this is where I need to think. Well, I might this might be a dynamic programming question, so let me, if I try to define some DP state, because if I try to define a DP state, then a DP state should have only one state, or else it is even if there are multiple states, those states shouldn't add to the time complexity. So maybe let's say define dp of I to be equal to, like, what is the no, I think this shouldn't be with, this cannot be done with dp. Or maybe monotonic stack will do. I need to, like, for a particular forbidden, let's say I have forbidden of I, and where is that value? That is what I need to get. Yeah, I can actually also, like, uh, so let's say I am in the index 1 and I see that the forbidden of I well, okay, this is, I cannot also use hashing techniques because of this. I can use hashing technique of n log n maybe. Yeah, I can do that. I can use multiple maps and try to do it. Like, for example, I can actually have, like, if I am at index 1, I can just for index 1, so the first thing that I'll do, even if I use hashing techniques, I'm still not in a position to delete. Maybe yeah, I can map of sets I can use, yeah, for, like, let's say num of I will try to insert all of the, for a particular element, I'll try to figure out how many indexes are there. Like, I'll try to form a set of those where this particular index is there in terms of I, and then when I am trying to and when you are here, that this is not equal to that thing nums of I for a particular index, so I need to swap some values, correct? Whenever I find out that yeah, okay, I'll have to swap the values basically, and I'll also need to know from which index am I swapping. If, let's say, let's say there is a index of something that I don't know, but there can be multiple, basically there can be multiple indexes where I can swap from. I need to choose that index which will try to guarantee in basically one swap both of the indexes are satisfied. I just need to check that, right? So yeah, I'll try to do my best. Okay, so this is going to be an n square, but I really don't want to do n square, so I'm thinking of something like better. Yeah, to avoid forbidden values. Yeah, okay, So like for example, I don't know if there will be, yeah, as you can see, this is just -1 straight away. I can just swap this with this, that's it. Yeah, I need to come up with there can be two things, right? Two things, which is first in one swap both the values get swapped, or only one value is swapped, right? These two are the things that can happen. So whenever I see an unequal, I'll increase this, right? But there can be values which are lesser than that. Then what can I do? I'll try to maximize these kinds of things. Okay, so for example, if I'm at index, in some index, and I see that they're not equal, then I'll try to search for that particular index which will solve this thing, basically, right? How can I do that? Okay, but before that, let me see what is this question. Maybe I can solve this question, maybe, I don't know. You are given an integer and an undirected tree. Okay, there is a tree 0 to 1 represented by, I know this thing. Okay, you are also given an integer group of length, this is the thing, labeled assigned to the node I. Okay, note you are considered part of the same group if group of u is equals to group of v. Okay, the interaction between u and v is defined as the number of edges on the unique path connecting them. On the unique path, the interaction. Okay, right. Unique path. I can find the number of unique path, but I cannot find the number of edges on the unique path connecting them in the tree. Alright, I think I can actually find a unique path. There can be multiple paths, correct, connecting from one particular. Can there not be multiple paths? There can be multiple paths if there was a cycle, but in this case it's a tree, and tree can never have multiple paths. So yeah, okay, this is correct, this is all right. I just need to find the number of edges between u and v. Okay, but I cannot do n square thing, right? So I need to be clever here. Right, all right. I might be able to do binary lifting here, because I just need to find let's say I have two things, up of I and up of j, right? I just need to find the common ancestor of these two things, right? Alright, once I find the common ancestor, what will I do? That is the question. Okay. How many edges? I just need to count how many edges I had. So to find the, I might be able to do it, but before that I want to do this thing. Maybe I will try to do binary lifting later. I think I will be able to solve it for some reason. For every index, the value of I is not equals to, there will be a swap. Right. Right. This is almost like a graph question. Wait, what? Why is it 0? Oh, okay. See guys, I understood the question wrong. I thought I needed to make nums equal to the forbidden, but that's not the case. So whatever I did here is actually wrong. All right. Okay, so when can I never? So I can never make nums of I. Like there is always one value, like which will always match with some value of forbidden. When will it be possible? When is it possible that I can always, no matter what I do, I will always end up, having some value in forbidden. So there will always exist a number, either 2 is common, so 2 is common when I do it in this way, but when I do it in other way, let's say 2 is not common but 3 is common. I just need to have forbidden values. If all of the forbidden values are same, there exists one element which is same as forbidden value, then I will say that it can never become. So let's say that nums of I is equal to forbidden. So I can swap nums of I with somebody. And who am I going to swap this nums of I with, nums of 1 with? That is the question. I can swap with somebody. Yeah, I can swap it with somebody who let me think. I can swap it with somebody which also shares a common, I can see that I don't want to make this equal, and there is something else, other indexes which is equal, then I am just going to swap those values, correct, which is also equal. Once I finish most of the equals, okay, alright, I'll remain with one forbidden maybe which is equal, and that forbidden I just need to find out, for that forbidden I just need to find out, okay, yeah, I think I got it. Yeah, I might be able to do it. So the first thing I need to check is, for a particular index I just want to check if it's equal. So how many, whenever I found some index which has equal values, I try to mark the index of that value. So let's say now I am going to swap this number with some other equal number. I will choose a number which is not this guy, correct? That's what I'll do. So a map of vector can do it, I think. Map of vector. So what will I do? So for a particular nums of I, I'm going to insert, or maybe set will be better, because I will easily be able to delete or insert in a set, correct? So whenever I encounter something which is equal to this, I will try to swap this value with somebody else which is also equal but not equal to this number itself, correct? Yeah. Yeah, so yes, I don't actually need to do this thing. So if it's even, I can just no, I cannot do it. Right, I have to think about it. So there can be multiple same values, same valued things, correct? If there are same values, like this is equal but they also have same values, then what are you gonna do? You know that all have a different values now. So in the end, like what can you really do if all of them have same values? Interesting. So the only thing that I need to worry about is if there are multiple indexes I which is equal with forbidden, and if they are all the same values, then what you're gonna do? Well, this is equal to some value with this. I can swap with some forbidden here, correct? I can swap this number with some forbidden, with obviously I can swap only with nums, but that nums, but it's forbidden, it should not be equal to this, and this number is obviously equal, so I need to choose a number which is a different number than this, right? I have to choose a number which is different, and then the forbidden of that particular thing, like the number which is forbidden, it should not be same as this. So there are two things. One is I need to choose a different number, definitely, and I need to choose that number whose forbidden is not equal, whose forbidden value is different, or maybe whose index, that index, how do I find that index? Whose forbidden value is not the same, correct, right? And okay, alright, forbidden value is not the same, and this is also not same. Yeah. So let's say that these are all same values, right? And I'll have another set which will tell me different values. Okay, so this will be the different values, and this is going to be indexes. What are these going to be? Right, it's quite hard to think actually normally. Like, I forgot half the things. That's why you should write, because you will forget the half of the things. Yeah, let me drink some water. Yeah. Yeah, so in the beginning I will swap with, you know, so in the beginning I'll swap with values which are same. Correct. Then I'll think. The thing is this, I'll say values which are same. So which are same as in which are like, if this is also equal to this and there are other values also equal to this, basically which are same with forbidden. So same. Forbidden, same means forbidden of I is equals to nums of I. That's what I will do. So whenever I'm just only going to swap with these values. And now the thing is, how will I swap that? Is it going to be equal, or what is going to be the thing? So can I always swap it? I know I can always swap it, but let's say for example I have first index which is 2 for both of them. Okay, this is nums which is 2 and this is also 2. Okay, right, they both are same. And now I cannot really find a number because now I have to swap this with somebody, right? But if I swap it, I can only swap with something different, and let's say there are different numbers, but if I swap it, I cannot find a forbidden number. Basically I cannot find a forbidden number which is not equals to 2 and whose value is different, you know. I am not able to find a particular number whose value is same. So how can I do it? Like, if I am at a particular value and I am not finding a forbidden value I have to find, because I have to find a forbidden value which is not equals to 2, right? And its value, if it is not equals to 2, I have to find a value which is also not equals to 2. So both of the value shouldn't be equals to 2. If I want to swap this, both of these values shouldn't be equals to 2, right? This shouldn't be equals to 2, and I have to swap this. I can swap that with this, but if this is also 2, then I am doomed, correct? And when I cannot find such thing, then I am done. Then I can say that it's not possible, right? Because both shouldn't be 2. That's the thing. So it can be, if it can be 6 and it can be 7. Both together shouldn't be 2. So this will obviously not be 2. This shouldn't be 2. If everything is 2, then I cannot do anything. But in the upper value, like that also shouldn't be 2, because once you swap it, it's still the same. It's still same. You need to find a value which, so something like this can happen, correct? Yeah, I found out. Something like this can happen. Like these are really alright, correct? This doesn't really have any problem, this thing. But whatever you do, you really just cannot, like you can just keep adding values, correct? Something like 7, or maybe 2 and 1, or maybe 3 and 2 again here. So if you forget these values from the second index says these values are no way equal, so they are correctly fine, but you cannot still swap this with somebody else, correct? It will lead you to -1. So when this type of thing happens, you are done. You are just done. You cannot do anything, correct? Yeah. So yeah, so this will be my algorithm which I am thinking right now. Is I'll swap the values which are these kind of things at first, only swap amongst themselves which have this, I can, and then once I am done with this and there is only one thing left, then I'll try to find values which are both not 2. That's it, both not 2. Correct. Yeah, the indexes which are both not 6. Yeah, I think I will be able to do this. Yeah, so first I'll take a map of sets, and yeah, I'll take this, and if nums of I is equals to forbidden of I, okay, then I'll be like, okay, same of nums of I dot insert I, right? This is what I'll do. Okay, now the main thing comes. All right. while mp or same, maybe I should, yeah, maybe I should just call it mp for now. I'm just okay. While mp dot size, the map dot size is greater than 1, I am going to do the following things. What I'll do, I have auto it, which is mp dot begin, correct, and auto iterator 2, which is just okay it, and then I'm just going to do plus plus it 2, so it will move on to the, so I have iterator first for the first value and for the second value, and now I'm going to swap them, right? And when I swap them, right, they are not equal, so I can easily swap them. Yeah, I can swap them. Yeah. Okay, when I swap them, I'm going to, you know, yeah, so what I'll do is nums of, okay, swap nums of it dot it of second. Okay, this is going to give me the set, so second of begin, and then I'm just going to be like, okay, star, yeah, second dot begin dot star it dot second, and I'm going to go to the beginning of this, and this is, I'm going to swap this value with nums of it to of second dot begin, yeah, with this value, correct. This is what I'll do, and once I swap them, I'm just going to, you know, yeah, once I swap these values, they are no longer equal to the forbidden. I will delete those indexes from the set. So yeah, so it star, right, or yeah, it dot second will be the set, and what I'll do is erase it second of begin. Similarly for it to dot erase it to second dot begin. Okay, I just need the iterator, I don't need the actual value. Yeah. Now if this iterator will not change, I think, right, because it will actually change the values as far as I know. Now what I'll do, if it dot second dot size is dot empty, Yeah, so if it's empty, then I'll try to reduce it. If it too is second also empty, then I'll do else, I'll just delete. Okay, what I'll do is mp dot erase true. How am I going to erase both of them? Yeah, that's an issue. I cannot erase both of them, so I need to do it in a smart way. So if mp dot begin, if mp dot begin is, if mp dot begin is second is empty, I will dot erase mp dot begin. Yeah, I'll just erase that. I'll ask it again, if else auto it, else if it too of second is empty, then I'll erase it too. Now I'll ask the same thing again. If it has deleted once, then I'll delete it again. Yeah, so if this has done, this was done, then I'll just not need to do anything. Yes, and swap it. Okay, correct. And now in the end, if okay, when I swap it, I will try to have a counter equals to 0 and count plus plus. That's what I'll do. And if mp dot size is, or maybe mp dot empty, if there is nothing in the map, then return going to count return. Else, now I'll start to focus on this. So because there is only one thing in the map, right, I'm going to go here, yeah, right. Now the main thing is, how am I going to find it out? So there are this many values, and I just need to find out two forbidden values, or how many. So the map of begin dot second, this thing is going to contain, okay, I am really suspicious about how these things are, so I maybe try to do this. To just be extra sure, right, I don't want to be unsure about the things, just so that I don't get a wrong answer. Yeah. Now I have mp.begin, or maybe I should just have an iterator. Auto it equals to mp.begin, and this iterator will have a single value, and tot, let it be second dot size, correct? So this many values here I'll need to, these values I'll try to reduce these values. So for example, I have here there is only one size of 2, only one index, then I'll only find those indexes such as there is nothing in common. So yeah, let's try to do that. Equals to 0, I is less than n, I plus plus. I am going to see how many of them are actually nums of I. If nums of I is not equals to for b then of I, right? I think I'm just no worries. Even if they're equal, I'm still fine with that. So if nums of I is not equals to it dot first, and then for b then of I is also not equals to it dot first, then I'll do this thing, dot minus minus. So if okay, instead of doing this, try to have a counter equals to 0, right? Yeah, I'll increase the counter instead, counter plus plus, and dot minus minus. Yeah, no, I'm not going to increase counter, I'm just going to have value int count 1 equals to 0. Going to increase this. If I have this thing, if this is the thing, then return count plus dot, else return minus 1. That's it. I hope this works, man. I hope this works. Wait, why is there no? 1 2, oh my god, is it working? Is it working? I don't know. Is it working? It didn't work. Wow. It didn't work. It just didn't work. Ah. Okay, so let's see what is wrong with this. 1 2 3 4 5 6 7. Oh wait, let me try to do this. Okay, so first is we have 239 with us, we have 297 with us, we have 285, 201, and then we also have 70, 98, 297 again, and then 3, and then nothing else. So the first thing that we will do is sort this out. 370, 98, then 239, I think, 285, oh 201, I forgot about 201, and then 285, 297. Yeah, after I sort this out, I am going to decrease values. 1 2 3 4. Yeah, so my algorithm should work. I don't know why is it not working. Why the heck is it not working? Oh wait. Okay, 1 and 2 and 3 and 4. Yeah, it should work. What is going on here? It 1.second erase the beginning thing. It 2. Erase the beginning. Yes, okay. So now if second is empty, like what is wrong? I'm not able to, this should give me 5, right? Is it like, okay, like what? Yeah, so I think I'm not considering if only if the first was empty, or it 2.second is empty. Oh my god. Yeah, okay, right. Ah, what's wrong? What's wrong? What's wrong? That is what I am. Like, my algorithm should have been given this. Like, I'm not understanding. Where is the problem? Where is the problem? This is just literally implementation problem. Nothing else. There is nothing. If this is the first thing is empty, then this thing, if again I find it empty, if it did find empty, then it will again find this. If it didn't find empty, then it will do this, and it will erase the second iterator. And mp.begin.second.empty. If it finds that it's empty, I'll erase it. If it sees that it's not empty, then I'll not erase it. It'll see that the second is empty. Let's say if it says that the second is empty, then I'll erase it. If I erase it, then I'll erase it again. See if it's empty again. If it's empty, I erase it. If it's empty again, I again erase it. Yeah, so it will erase, or if only the first is empty, then this erase it, and then it will erase the second also. But if it first is not empty, only the second is empty, then this. But what if only the first is empty? So it will do this, and then it will come here, and then again. What's the issue? What is the issue? তাড়াতাড়ি I don't think this is really a problem. I don't really think this is a problem. I'll not do this. What's relation? How my algorithm is even giving 5? I don't understand. Like, it's clearly my algorithm should have given 4. What? 370 98 10 it is this. What is the reason? The only possible reason will be something to do with this. When I swap it, it's completely fine. When I try to erase something, second, and I try to erase, do the iterator change? I don't think it should change, correct? I'm just erasing its begin. It will not change iterator 2. Then what I'm doing is I'm doing this thing empty. Once it erases that, I'm again doing this thing, and I'm again trying to erase it. I'm erasing 2 of the things. But what if the second was empty? I don't think I'm trying to apply. Okay, so 239 will have 0, and then 297 will have I could have also done with a vector though. 285 3 201 4 201 is 4 3 this 4 5 6 and 7 70 is 7. This is 8. Yeah, 98 is it. 219 9 and 10, so this will be 10. 11 12 13 14 15 15 16 17. Okay, firstly this and this are going to be checked, correct? These 2 are going to be checked, and we will be like, okay, yeah, mp dot size is obviously greater than 1, so yeah, we will do this thing. If mp is not empty, then there's nothing we can do. Yeah, so I'll do this. I you know what, I really don't think doing this will do any different. I think what I should do is always whenever I erase, I redefine this thing. So it equals to mp dot begin, it2 is equals to it, and plus plus it2. I am redefining this thing again and again. Here I am deleting, again I will do that. I deleted this, this is not an issue, but when I have done this, okay, now I think it should be the correct, give me everything correctly. Where is the problem? Last one is still 5, so it was not an issue. What is wrong, guys? Just exactly what is wrong here? Somebody tell me, please. Like, where I am doing the mistake? Just where? I don't understand. I don't understand. I don't really understand. I'm doing a mistake here. Like, should it be like something? Oh, okay. Wait. No, that's not an issue. That is not an issue. Fuck. Just absolutely fucked up. Okay, so here I'll be checking this and this at first, and I'll be like, okay, swap them, so there will be a value with them. It dot second dot begin, and whatever the value is, I'll swap that with the second one, whichever value is that. So basically what I'm doing is swapping this, swapping this and this, and then I'll erasing the second dot begin, so this will go, and it 2 dots begin, this will also go. So now this will have something like this, and now it will check if mp.second.empty, mp.begin.second.empty. So mp.begin is this and second is empty. Yes, it's true. Then mp. is mp.begin. So I'll reduce this, and then I'll not go here. I'll again go here, and I'll again check if mp.begin.second is empty. What is mp.begin? This, yes, it's empty. mp.erase.mp.begin. Yeah, so it will erase this thing. Similarly, I'll go, and 98 is 98 and 201. This is count is now 2. Count is 2. Now I'll have this here, and I'll have this here. Again the count is 3. Reduce this, reduce this, the count is 3. Okay, I got it now. Fuck. Now I got it. Why it was it is, it's not, it's, it doesn't have to do anything. This doesn't have to do anything. This is the reason, because there are two things. Yeah. Oh man. I didn't think of this. Yeah. Yeah, so I won't be able to do it. I think I need to now these two things, whatever. Okay, I forgot to check my rank. Let's see, I think it's 5-digit rank most probably. Okay, we are safe. It's 4-digit only because I've solved. Oh wait, what happened? Yeah, it's 4 digits still. I don't know how, because I think I've solved it very fast. The first question is like, it was, I think I've done it already before, that's why I was able to do it again. Now third and the fourth question. Now there is something that I learned today, correct? Yeah. So yeah, that's it for this video. We will maybe I'll try to learn that, and I most probably make a third video too also today. Maybe, we don't know. If I get some chance, then I'll definitely be making another video. Yeah, this was hard, and this logic was not correct. Whichever logic I have done here, it was definitely not correct. Should have been a priority queue of these sets. I think the oh man, I should have used priority queue. I think I got how to do it, but I'll obviously have something better somehow. And instead of a set, I think I should have used, I don't know. Yeah, I think I can solve this. Instead of taking map, okay, I'll take a priority queue instead. So priority queue, QUE, and yeah, this is fine. This is also fine, set, but this should be of a pair, right? So maybe yeah, PQ, right? PQ. What I'll do is, this will be the length. Maybe yeah, I'll have a map again. Yeah, I can actually try to do a really long, make a really long solution, but I really don't want to do that. I can use priority queue to to some extent. It will be very beneficial, obviously. The swapping will be wrong. Let's try to you know what, just do it. Just sometimes we should just do it, right? And obviously I don't have something for this. I cannot use array because it doesn't store different. I think it stored the same thing, so I will need to use, yeah, and instead of, let's say, set, let me use vectors, which is better. And in this case I'll use a pair or array. This is the first thing is just going to give me the length. The second thing is going to give me the, oh wait, yeah, I think priority queue is also not going to work. Wait, let me just think about it for a moment. I will have nums of I and I'll have some set. I just want this to have a comparator, so I just need to make a comparator, I think, yeah, comparator of, can I make a comparator of the value of the set? You know, can I make a custom comparator for a map? Let's ask ChatGPT. Yeah, I mean, I just, you know, I still will not be able to do it. Comparator for maps. Let's say I have this and I want to compare by the size of the vector int. Can I do this? Yeah, this is what I want. No, not directly. Only compares keys, not values. Yeah, I know that. Okay, I think, yeah. Don't do this. Yeah, I know that. I didn't know that, but you can do instead, if you want to iterate by vector size, copy the vector and sort. Okay, I think I should, it's better to watch that tutorial, I think. Well, this was almost correct. The only problem is yeah, let's try to see the solution for this one. Okay guys, that's it. I think I'll see the solution myself. Okay, bye bye, take care.